All right, Titans, we're back for another week of distance learning. Hope you had a good weekend. I enjoyed reading your answers to the questions last week about what you would do with $1 million. I thought it was really cool how many of you were going to give it to charity or try to stop COVID-19 or give it to your parents for all that they've done for you. A lot of pretty cool answers. So it got me thinking about some jokes about money, right? So Calvin's here. He's going to try to answer these jokes. Calvin, what did the duck say after he went shopping?
What?
Put it on my bill! Speaking of bills, Calvin, how do dinosaurs pay their bills?
I don't know.
With Tyrannosaurus checks. Alright, see you later, bud. Alright, so this week we're getting into a different area of quadratics, which is actually going to come back to practicing the quadratic formula and other methods of solving quadratics. Today we're going to work on introducing the idea of systems of equations, which systems of equations are something we did in IM1. So hopefully this will kind of ring a few bells as we get going. So I'm back to the problem that we did last Thursday about the dog owner trying to build a rectangular enclosure. And we talked a lot about the maximum and how 25 was the width and it would give you the maximum area, right? We did questions like that. We talked about the x-intercepts. But we purposely left off a couple of questions because they lead perfectly into what a system of equations is and how we can use it to solve problems. So the first new question is, how can the owner create an enclosure with an area of 800 feet squared? So to do this, if we have a graph, we can estimate an answer really easily just by looking at the graph. If the area is 800 feet squared, and we know the area in feet squared is our y value, or our y coordinate, we can just find where 800 is on the y-axis, which would be right here. And then we can draw a horizontal line and find where that horizontal line hits the parabola. So this one, it actually hits nicely on a corner. This is the ordered pair 10, 800. And then this second one is at 40, 800. So the first thing that hopefully you notice is there's not one answer to this. There's actually two. Because as the parabola is going up, we find one location where we can get an area of 800 feet squared. And at this particular area, the 10 is representing our width. So we know that to create an enclosure with an area of 800 feet squared, they can do it with a width of 10 feet. So if their rectangle had a width of 10 feet, their area would be 800 feet squared. But that's as our parabola is increasing. As the parabola begins to decrease, right here we hit 800 again, which means there's not just one way to get an area of 800 feet squared, there are two ways. So this point right here, 40, 800, means that we could also have a width of 40 feet. So how can the owner create an enclosure with an area of 800 feet squared? Well, they can do it with a width of 10 feet, or with a width of 40 feet. So there are two different possible solutions. So with a system of equations, which is what we're going to get to, we end up with one graph, right, our parabola. We had a second graph, which was our line, and our solutions to this system was where the two graphs crossed. And in this case, they crossed at two different places. Similarly, we could use the idea of a system of equations for finding what the area would be if our width was 30 feet. Because if we're talking about the width, we know that's referring to our x's. So if our x is 30 feet, I go to 30, so 10, 20, 30. And then I find where that value hits the graph. So if I draw a vertical line this time, I can see that that hits the parabola right here, which is the ordered pair 30, 1200. So I know that if the width is 30 feet, my area will be 1,200 or 1,200 feet squared. So if the width is 30 feet, the area would be 1,200 feet squared. And again, all we did was we took our parabola, which was one equation, right? This equation here. And then we take our vertical line, which is our second equation or our second graph, and we find where they intersect. Okay, so we can do the same thing with our model rocket. We've got the rocket going up in the air. It's reaching its maximum height in 4.25 seconds. But the question is, when will the rocket be at a height of 180 feet? And so to find that, we go to our height, which was our y. We go to 180 feet, which is right here. And then we draw a horizontal line. Now, when we ask this question on tests, a lot of the times people only gave us one answer. They would go right here, and they'd find, oh, right there, let's see, 180 feet. Well, that looks like it's a little bit less than 2 seconds. So maybe they put 2 seconds. But is there more than one place where the rocket reaches a height of 180 feet? Because sure, it reached 180 feet in about 2 seconds, but then it went up and it came down, and eventually, how high is the rocket at this point? Well, it's still about 180 feet. And it looks like that's at about 7 seconds. So by looking at the graph, we can approximate that the rocket will be at a height of 180 feet at about 2 seconds and about 7 seconds. Now, this one bothered me a little bit as I'm looking at it, because right here and right here, it's not perfectly on a corner. So the answers aren't exactly 2 and 7. So how can I find the exact answers? Well, we can plot the graph on Desmos, and we can find exactly where they cross. So guess what? That's what I did. So if I go into Desmos, and I type in those two functions, so the first one is my parabola. This was the equation that we used to show the model rocket, so that's my blue. And then the second one, I typed in y equals 180. Because what did our y-axis represent? Well, our y-axis was the height. So I want my y value to be 180. So I simply type in y equals 180, and that gives me a horizontal line. And now to find the exact answers, I can go to these points of intersection, and I can see that, in fact, it was a little bit less than 2 seconds. It was 1.64. So I know after 1.64 seconds, the rocket will be at 180 feet. But I also know that as it comes back down, it reaches 180 feet again, and that was at a time of 6.86 seconds. So to get exact answers, we can always graph both of them on Desmos, find where the two equations cross or the two graphs cross, and those will be our solutions. So 1.64 and 6.86. So 1.64 and 6.86. So if we just have a picture of the graph, we can get a pretty good approximation. But if we want the exact answers, we can always type it into Desmos and find where they cross. Our third and final example that we're going to look at was when Angelo threw the football from the top of the building that was 80 feet tall, and then it went to the ground below, right? So here's Angelo, here's the building, he throws that football up, and then it goes and hits the ground. Okay. When will the football be at a height of 80 feet above the ground? Well, again, we want to know when the height is 80 feet. So we go to a height of 80 feet, which is right here, and we draw a horizontal line. So that actually includes my y-intercept, which was 0, 80. So 0 represented the time. So to get to a height of 80 feet, one of the times it was there was at 0 seconds. So when will the football be at a height of 80 feet? At 0 seconds. Which, what does that actually mean? Well, that means when he threw the football, right? So when it left his hands, it was 80 feet above the ground. But we also know that because the football went up and then came back down, there was another time at which the football was 80 feet above the ground. And so I can look at this ordered pair, which is 4, 80. And I know that to get to a height of 80 feet, that will also occur at 4. 4 is my x is time in seconds. So it also reaches 80 feet 4 seconds after he throws the football. So it'll reach 80 feet at 0 seconds and at 4 seconds. So anytime we have a quadratic and a linear, it's possible to get as many as 2 solutions. So can we do all of this without a graph? Now you're probably thinking, why would I do that if I could just type it in Desmos? And well, it's because we want you to practice, we want you to sharpen your skills, and these are the types of questions we're going to ask for evidence for. So hopefully by the end of this week, you'll be able to do this without a graph, and you'll find it to be a good review of solving quadratics as well. So as far as how we can do that, well, we know that the equation for the dog enclosure was a of w equals negative 2w squared plus 100w. Well, a of w is our area, which is really our y coordinate. And then w is our width, which is our x. So I'm just going to replace the a of w with y and the w with x. And we get a nice quadratic equation. I can do the same thing for the area of 800 feet squared. If I go to my area of 800 feet squared, which we said was right here, well, that's a horizontal line going through the y-axis. So that's the equation y equals 800. So how do I take this and get solutions? Well, you might remember from IM1, we had what we called substitution. If y equals this, where can we substitute this in? Well, since it's what y equals, we can substitute it right there. And we can come up with a new equation of negative 2x squared plus 100x equals 800. And for today, we're not going to solve it, but starting tomorrow, we're going to solve a bunch of these. So this is just to kind of get you understanding how we're going to set these problems up. Likewise, for finding what the area would be when the width is 30, we can take the equation of the parabola, which was this equation again. So y equals negative 2x squared plus 100x. But now for my second equation, I'm finding when the width is 30. The width is my x, right? And to get a vertical line, it's not going to be y equals, because that's what we did for a horizontal line. It's going to be x equals. So I'm going to do x equals 30. And on this one, we're actually going to, since we know that x is 30, we're going to take this, and where can we plug in 30? Well, since it's what x equals, we can plug it in for x and x. Long story short, I'm not going to write all these down, but we write one equation, we write the second, and then we can substitute. Actually, I will do this one just for one other example. For the parabola, for our rocket, I can replace h of t with y. I can replace t with x, because t is representing my x-axis. And so I get negative 16x squared plus 136x. And then my second equation, for when it reaches 180 feet, is just the equation y equals 180. And so to be able to solve this, I can substitute this in for y, because that's what y equals. And we end up with a new equation of negative 16x squared plus 136x equals 180. And you might be thinking to yourself, how am I going to solve this? Well, we're going to put it in standard form. We're going to use the quadratic formula, but not today. All right, same thing with the football. If I confused you a little bit with how we set up those equations, don't worry about it yet. I promise tomorrow when we start solving them, it'll make more sense. But the key idea for today that we wanted to make sure you understood is if we have one graph and we plot a second graph, the solutions are where the two graphs cross. So we're trying to find all of the places that those two graphs have in common. When we do that, that's called a system of equations because we're taking two separate equations and finding their common solutions. Something we did in IM1. And I can't wait to do more of it with you later this week. So that's it for today. Hope you guys are doing well, and go Titans.